Alright, we're going to balance a second basic solution equation. So on this one, the same thing applies in terms of we may add OH minus or H2O. We don't have to add both. We can add either. Okay, and we're going to work it through. Alright, I'm going to start with ClO minus, so that would be the hypochlorite ion. Goes to chloride ion. Chromite goes to chromate. And again, it doesn't matter which one we work first. Since I have this one up here, we have oxygen present on this side. We have no oxygen on this side. So because the oxygens go up singly with oxygen but doubly with hydrogen, so it already has an oxygen, so we're going to put the water on this side. I'm going to put the hydroxide on this side. And this gives me 2 oxygens and 2 hydrogens. Well, that's convenient, because then if I put 2 hydroxides, then I have balance with respect to the mass balance. 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens, chlorine and chlorine. Total charge on the reactant side is 1 minus. Total charge on the product side is 3 minus. Therefore, I need to add 2 electrons. That makes this, the electrons are gained, so that's a reduction half reaction. Alright, so coming down here, we have 2 oxygens on this side, 4 oxygens on this side, so probably the water is going to go on this side. Now, it's a general rule of thumb, doesn't always work that way, but it usually works. And like a similar problem we worked before, where we have 4 oxygens here and 2 oxygens here, the easiest thing to try, it doesn't always work, but let's make 4 oxygens here, so we have 4 and 6, which 4 and 2, which is 6. So if that's 4, this should be 2. Well, if we now look at it, our oxygens are balanced. We have 4 hydrogens and 4 hydrogens. That's convenient. Okay. OHs are usually the hardest to balance. Now we have a 5 plus on this side. We have a 2 minus on this side. So we're going to add 3 electrons on this side. Now that means we gained 2 electrons here. We lost 3 electrons here. What's the smallest number that both will go into? 6. So we're going to multiply the top equation by 3, the bottom equation by 2, so that our electrons cancel. So that being the case, we have 3 waters plus 3 ClO minus plus 8 hydroxides plus 2 CrO2 minus yields 3 chloride ions plus 6 hydroxides plus 2 CrO4 2 minus plus 4 waters. Now I know because we have waters and hydroxides on both sides, they're going to have to cancel. So I have 3 waters here, 4 waters here. So let's eliminate this. We have a 1 here. That's not going to be the same. But we have 8 hydroxides on this side and 6 hydroxides on that side. So we end up with 3 ClO minus plus 2 OH minus plus 2 CrO2 minus yields 3 Cl minus plus 2 CrO4 2 minus plus water. Double check it. 3 chlorines, 3 chlorines, 3 oxygens, 2 oxygens, 5 oxygens, and 4 oxygens is 9 oxygens, 8, 9 oxygens, 2 chromiums, 2 chromiums. Total charge 3 minus plus 2 minus is 5 minus plus 2 minus is 7 minus. 3 minus plus 4 minus is 7 minus. So we're balanced mass and charge. Okay, now word to the wise, we happen to have hydroxide on one side and water on the other side. Be careful if they give it to you in the top equation, because it may not end up where they put it. Also, I have balanced equations where I had both the hydroxide or the hydronium H plus on the same side as the water. Most of the time they're opposite, but not always. Okay, so let's go back and double check this. We're gaining electrons. So since we're gaining the electrons, this is the red part. We're losing the electrons. So this is the ox part. So if we're trying to ID the species, we got to go back to the oxidation numbers. Oxygen is 2- because we have a -1 charge. This wants to be, or this needs to be 1+. Oxygen is still 2- here. 2 times 2- is 4-. So we have to have 3+ plus 4- gives us a -1 charge. This is -1. Oxygen is 2- here. 4 times -2 is -8. So chromium needs to be 6+ here. So our oxidized species is going to be chromium. Our reduced element is going to be chlorine. Chromium is going from 3+ to 6+, and chloride is going from 1+ to 1-. Okay, so we have a difference of 2 electrons here. We have a difference of 3 there, so that's why this gets multiplied by 2 and this one gets multiplied by 3, so that we have 6 electrons total. So we've just balanced our second equation in a basic solution.